Okay, so welcome. We're going to talk about the polynomials now. Like if we have a factored format and we want to write it in standard format, we're going to need to do a little bit of algebra. So one of the things that's I kind of thought was important here is understanding what a y-coordinate is. Right? And the y-coordinate is if we have a 0 substituted in for x. So watch what happens here. If I substitute in a 0 here, and then I substitute in a 0 here, and then a 0 here, and then another 0 here, okay, what's going to happen? Okay, this becomes 0, right? This becomes 0, this becomes 0. That remains a 9, and then this is also a 0. So you would say f of 0 is equal to 9. So really, the y-coordinate in standard form is just a constant, right? It's just going to be the constant, okay? Even though this wasn't technically written in standard form. But we have a additive and subtracting, additive relationship right here, okay? So now, if you have two binomials that you're multiplying, this is where you want to carefully substitute in. So I've got 2 0 squared plus 5, and then 0 plus 1 quantity squared. Okay, so you want to be careful here because if I say f of 0 is equal to 2 times, what happens here is 0 squared plus 5 is 5. And then 0 plus 1 is 1 quantity squared. So we would say our f of 0 is 2 times 5 is 10. 10 times 1 is 10, right? So the y-coordinate of the y-intercept is given to you in both of these values right here. Okay, so just be familiar with that because the algebra kind of comes into play when you're writing things in standard form here. It's a good way to check if you know the y-intercept, if you look at the graph and you write something in standard form. Okay, now how would I write this factored equation in a standard form? And look how I set up my binomials here. Okay, you can see that I've got the x plus 2 and then the x plus 3. It's really this just first half right here. Okay, that's going to go in the first binomial, or the first area model. And then this guy, I'm just gonna tack him on over here and create a longer quadrant. Okay, and you're gonna see why in a second. All right, so the first one, we've had a lot of practice doing this. So x squared, this becomes plus 2x, this becomes plus 3x, and this becomes plus 6 here. Notice that we combine like terms, and now what we have is a trinomial. So I'm going to take this trinomial and then write it over here. So I'm going to get x squared, 3x plus 2x is plus 5x, and then we've got the plus 6. So now you can see we've got a 2 by 3 box that we can use, and we're going to just fill in this area model. Okay, so x squared times x is x to the third power. 5x times x is 5x squared, and 6 times x is 6x. Notice that this remains positive, and also one thing I'd like to notice is if you read it in standard form, these will be in decreasing order. The x values will be decreasing. Okay, now this bottom box will be 4x squared. 4 times 5x is 20x, and then 4 times 6 is 24, and these are also all positive. This is going to work out nice and neat. So what we need to think about here, and this is why the area model is really nice, is the diagonals here, in this case, will always be like terms. So if I'm going to write my function in standard form, I'm going to say f of x is equal to x to the third is the first. And the next thing I'm going to look at is, well, I want to travel in this direction right here. And I'm going to add 5x squared plus 4x squared is plus 9x squared. And then I'm going to look at the third diagonal right here. And notice that 6x plus 20x is plus 26x. And then my last and final number at the end, which is the constant, which is all by himself, will be 24. So there you go. Now you have your equation written in standard form. Things to think about. The constant is the y-intercept, right? So this is a very nice way to kind of check your work and understand that that constant value right here, this is going to be the y-intercept. Very clearly, because if I plugged a 0 in for all of the x's, all of them would disappear, and the only thing left would be 24. So that's why standard form is kind of important. So next and last example, which I wanted to show you, is notice how I have an a value now. So this is the way I like to set these equations up. I'm going to take these first two and deal with it in my first area model. Then I'm going to apply this third one down here. And then I'm going to leave this -3 till the very end. I'm going to leave the -3 till the very, very end. Okay, so let's do it. All right, x times x is x squared, x times -1 is -x, x times 5 is 5x, and 5 times -1 is -5. Okay, so the next step is move it over here. All right, so I've got x squared, and again, remember, diagonals become like terms in these area models. So 5x minus x is plus 4x. And then I've got a -5 tacked on here to the end as the constant of the first multiplication. And now I'm just going to fill in here, right? So x squared times x is x to the third. And then I've got 4x times x is plus 4x squared. And then x times -5 is -5x. Notice how we are descending order, right? X to the third, x squared, and then technically x to the first. Now I'll fill out the bottom row, and then we're going to get 7x squared, and then 7 times 4x is plus 28x, and then 7 times 5 is -35. So there we go. Now we're trying to fill in our diagonals here. Right, so with our diagonals, the first one we're going to get x to the third is just going to be by themselves right there. And then I look at this diagonal, and I've got 7x squared plus 4x squared is plus 11x squared. And then I've got -5x and positive 28x, which will give us plus 23x. And then again, the constant is -35. So I'm just going to write this -35 all by themselves. And this is the last and final step where I want to incorporate that -3 in. So I would say f of x is equal to, now I'm just going to distribute here all the way through. So -3 times x to the third would be -3x to the third. And then we're going to get -33x squared. And then we're going to get -69x. And then we're going to get plus 105. Okay, use your calculator if you need to check and make sure that you are correct. Okay, all right, hope this helps y'all.